All right. So let's get back to what we were talking about. Right, what were we doing last time? Last time, still on this number theory. So last time we talked about prime numbers. And today we're going to continue with more number theory, but today is going to be about greatest common divisors. And maybe some other little things. So let's start by defining what this means. So it's basically what it sounds like, but let's write it down. Let's say we have two integers, and they are not both 0. Then their greatest common divisor which we write GCD for obvious reasons. The greatest common divisor is the largest integer d such that b divides a and b divides b. So again, basically what it sounds like, it's the biggest integer that is a divisor of both a and b. And a related definition, so this is greatest common divisor, related definition, a and b are called relatively prime if their greatest common divisor is 1, which essentially means they have no common prime factors. So let's look at some examples of this. So let's just pick two numbers and write down some divisors. So the divisors of 24, what are they? Well, I've prepared a list, so we don't need to think about it too much. 1, 2, 3, 4, 6, 8, 12, and 24. So I guess this should be 2 times 2 times 2 times 3. And these are all the combinations you can make of those factors. And if we take something else, maybe 28. So this is 2 times 2 times 7. So its divisors are 1, 2, 4, 7, 14, and 28. So what is the greatest common divisor of these two things? Well, what divisors do they have in common? These ones, and that is all. So we just look at this list, and the greatest common divisor is 4. Another example. The divisors of 17. Well, 17 is a prime, so it's just 1 and 17. And let's say 22 is 2 times 11. So the factors are those. So again, comparing these lists, we find their greatest common divisor this time is 1. So we say they are relatively prime. Cool. So certainly writing down all the factors is not the only way of doing this. Maybe an easier way, if you know the prime factorization, is that you can read it off from the prime factorization. So if we have prime factorization, you can read off the smaller exponent of each prime. And that will give you the greatest common divisor. Let's do a quick example of that. So here are some big numbers with some prime factorizations. This is 2 cubed times 3 squared times 5 times 7 squared. And this is 2 squared times 3 cubed times 7 times 13. So what is the greatest common divisor of these two numbers? Well, for each prime, let's just look at the two exponents and take the smaller one, right? And this is going to give us the greatest common divisor because we're essentially taking the greatest power of each prime that divides both of them. So in this case, the smaller exponent is 2. So the greatest common divisor will have 2 to the 2. And then for 3, we look at the two exponents, and the lower one, again, is 2. For 5 does not appear at all in the second guy. So we will have to leave him out entirely. And then 7, we have 7 squared and 7 to the 1. So we get a 7 to the 1. And then no 13 on this side either. So that is it. And this is, what is this? I guess this is 252, according to my notes. Okay, and then let's introduce a little bit less common but related operation. The least common multiple which is LCM, again, for obvious reasons. The least common multiple LCM of A and B is, again, what it sounds like, the smallest positive integer let's give it a name, M, such that A divides M and B divides M. So again, it's just the smallest integer that is a multiple of both A and B. And how can we find this? Well, you could start writing down multiples and see which one is the smallest. That could be a little bit annoying. If you have the prime factorization, again, you can just read it off from there. So let's do this same example. What is the least common multiple? In this case, if we're doing least common multiple, we look at the exponents and we take the bigger one, because that is the smallest number that you can get by adding factors. So we will have a 2 to the third, since that's the larger of the two exponents. We will have a 3 to the third. We will have a 5, because it appears once here and 0 times there. We need 7 squared coming from this guy, and we need a 13 coming from this guy. Okay, and then this is, some number. Maybe just let me write it down what it is. 6, 8, 7, 9, 6, 0. So this is the least common multiple of these two numbers. And a quick question: what is the greatest common divisor of some number and 0? Or rather, what is the question is really, is this equal to A for any A? And the answer is yes. So every number is a divisor of 0, except for 0. But everything is a divisor of 0, so the greatest common divisor of 0 and anything else is going to be the greatest divisor of that thing, which is itself. Very good. So let me make a note of this.